Hello and welcome to today's screencast. So what we're going to be focusing on is the recovery process, specifically this term EPOC here. So if we just think back to what we did last lesson, we looked at the energy continuum and specifically how the interplay of energy systems takes place with regards to intermittent exercise, for example invasion games, and how the energy systems interplay with each other to produce energy. Now what we're talking about is the recovery process. So now we have kind of played or taken part in an activity such as a rugby game, football game, netball game. After that, we're going to be looking at what happens. So how do we recover? What happens to ensure that we recover our processes that allow us to exercise again the next day or the week after, and so on. So we're going to first of all take a look at the specification for recovery. What we need to know is how the body returns to its pre-exercise state, specifically EPOC. Now EPOC stands for excess post-exercise oxygen consumption. It is basically saying the volume of oxygen required post-exercise to return the body to pre-exercise state. So it's that excess post-exercise, after exercise oxygen consumption. Now, if we look to the right here, we have got a graph here or a figure that's showing oxygen consumption during exercise and recovery. If we look at recovery starts from 0 minutes here through until our systems are fully recovered. So we are looking here at, you can see that it actually starts as a fairly rapid kind of decrease followed by a gradual decrease. Now there's two parts to EPOC. We've got the first and fast component, which is A here, also known as the alactacid det or alactacid part of EPOC, and then we also had the second and slow component of EPOC, which is the lactacid component of EPOC. Okay, so first of all, first and fast component A, second and slow component D here. And as you can see, it goes on for a longer period of time than the first gradual decrease that takes place here. So EPOC, it's the excess post-exercise oxygen consumption. What else do we need to know? So I've spoken about the fast component of EPOC. This process now that occurs here in A. So we're talking what happens in A here, and what we need to look at here is the replenishment of blood and muscle oxygen stores, i.e. our hemoglobin or oxyhemoglobin stores, and our muscle stores, our myoglobin stores, so oxymyoglobin stores. And then we also need to look at the resynthesis of ATP and our PC stores, which we're going to go on to in more detail when we go on to the screencast. So the second and slow component we're going to do in our second screencast, and what we need to be talking about here is the elevated circulation, ventilation, body temperature, and that removal of lactate and the conversion of glycogen, so kind of getting our glycogen stores back again. So remember, this is the specification, this is everything that we need to know with regards to EPOC or recovery. And finally, we need to know the effect of exercise intensity on EPOC and the implications of the recovery process for planning exercise or training sessions. So EPOC is always present regardless of the intensity of the exercise. Okay, so however, the size of oxygen kind of deficit or EPOC may differ depending on activity intensity and duration, i.e. if the activity is really high intensity, EPOC may take a bit longer than if the exercise was of a low intensity aerobically. So that may take, EPOC may last a little bit less, or recovery may be a little bit less. But that's what we're going to be going on about in today's screencast. So this is a typical exam question. So within the first few minutes following exercise, explain how the body starts to recover the process. The first few minutes we're talking about the first and fast components of EPOC, which we're going to know at the end of this screencast here. If you look at this second question here, this is actually a 20 mark, and this is on the new specification. So this is the only question we've had on the new specification regarding recovery. So it's in two parts really. So a team game such as basketball provides opportunities for recovery from high intensity work both during and after the match. There's your scene setter. Outline the recovery processes that occur in the first 3 minutes after exercise, and using a team game of your choice, evaluate the strategies that a player or coach can use to maximise recovery. And then the third part is evaluate the nutritional ergogenic aids that help the recovery process. 20 marks, a lot to get done. Obviously we need to go on about ergogenic aids, but this recovery process is what we're going to be doing over the next few lessons. So, first of all, the body returns to its pre-exercise state by using EPOC, which is excess post-exercise oxygen consumption, i.e. that volume of oxygen consumed post-exercise to return the body to that pre-exercise state. We need to be aware of there are two recovery processes with regards to EPOC. The first and fast component of EPOC, also known as the A-lactic acid. Basically, this means before lactic acid, so without lactic acid. And then the slow component of EPOC, lactacid, which is with lactic acid. So, during exercise, there is depletion of ATP and PC stores, which we should be aware of. It's the first things that actually go, and oxygen and myoglobin stores, as well as glycogen and lactic acid. The blue is what we're going to be going on about today with regards to the first and fast component of EPOC, and in red, glycogen and lactic acid. They're more of a slower component of EPOC. That takes a longer period of time to resynthesize our glycogen stores and to remove this lactic acid. So if we're talking about the first and fast component of EPOC, first of all, we're going to be going on about the key function of it, which is to replenish our ATP and our PC stores. If you think about it, ATP lasts for about 3 seconds, PC stores last for about 10 seconds. They're the first thing, the first energy kind of system that we use up, that we kind of run out of. Therefore, the first and fast component of EPOC, these are the first things that get replenished. So, it does this via aerobic system, okay? So when we are breathing in heavy, once we've stopped exercising, right, we are breathing heavily, that is EPOC. So you've exercised, you've had a gain, and after the exercise, you are going through EPOC, this excess post-exercise oxygen consumption. You are breathing heavily, your ventilation is increased, your circulation is increased. You are using your aerobic energy system. Okay, when you're breathing all this oxygen or air in, we're using our aerobic system at this point, and this allows energy to be produced, allowing for endothermic reactions to take place. Now, if you remember, endothermic, if we take the E here, we have energy, and this is where energy is used to fuse smaller elements into larger molecules. So for example, just a bit of a recap for you. I tell you what, if you think you can give this a go, pause it and think, how do you think our ATP and PC stores are replenished via endothermic reactions? Give it a go. Quickly go through it now. So we have E plus P plus ADP equals ATP. And then the other one, how do we get our PC stores back? Well, it's E plus P plus C equals PC. So it's really important, you know, the first and fast component of EPOC is also replenishing our ATP and PC stores, the first things that go when we exercise. Now, at high intensity, we do this aerobically using EPOC, that excess post-exercise oxygen consumption. We are working aerobically, and when we're working aerobically, we're producing endothermic reactions, okay? So energy is used to fuse smaller elements such as E plus P plus ADP to make ATP, E plus P plus C to make PC. And then that is restored. So that is the first component of EPOC with regard to the ATP and PC stores. And then excess oxygen available after exercise is due to the respiratory rates being high, as I've said, the circulatory rates remaining high, and remaining elevated following our exercise. Now, this uses 1 to 4 litres of oxygen. This is important to know. Okay, so the component, the first and fast component, shows a volume of oxygen required is to be about 1 to 4 litres for these initial jobs to be completed, i.e. the resynthesis of ATP and PC stores, and then the next one we're going to go on to, which is replenishment of hemoglobin or oxyhemoglobin and myoglobin, also known as oxymyoglobin. So if you think about it, when we have this increased respiratory rate, i.e. this increase in breathing, this increase in our circulatory rates, our blood flow, these remain elevated. It means we're breathing in more oxygen. If you think about this oxygen, gaseous exchange takes place in the alveoli and blood, which means that our hemoglobin gets more oxygen, oxyhemoglobin, and then when it's transported to the muscle, our myoglobin stores that were depleted due to exercise have now got oxygen attached to them, so they become oxymyoglobin. So the things that we need to be aware of, or the two main components of the first and fast component of EPOC, is replenishment of blood and muscle oxygen. We do that by having an elevated respiratory rate and circulatory rate. This means that oxygen binds with hemoglobin to make oxyhemoglobin, and oxygen binds with myoglobin to make oxymyoglobin. And then we also get the resynthesis of ATP and PC stores aerobically as well. And this takes approximately 1 to 4 litres of oxygen. Now, if you think back to when we did energy continuum and we looked at recovery Hopefully you remember that PC stores were replenished 50% in 30 seconds, and then they were fully replenished, and myoglobin stores are fully replenished after 3 minutes. Therefore, this system, this first and fast component of EPOC, lasts for approximately, or takes 3 minutes to be fully replenished. That is if the intensity of the exercise is really high. Okay, so if the exercise intensity is really high, the first and fast component of EPOC takes approximately 3 minutes, uses 1 to 4 litres of oxygen, and what it does is it replenishes our blood and muscle oxygen as well as our ATP and PC stores. So that is everything we need to know with regards to the first and fast component of EPOC. I'm going to go on about this E here, which is oxygen deficit in lesson. If we go on to the specification, this is what we've looked at. Okay, so how the body returns to its pre-exercise state is via EPOC, excess post-exercise oxygen consumption. We've looked at the first and fast component of EPOC, which is the process that occurs replenishment of blood oxygen, blood and muscle oxygen stores, and then finally the resynthesis of our ATP and PC stores. So that's everything to do with EPOC there. And if we look back to this, well, everything to do with the first and fast part of EPOC, we have looked at these two here. So our next screencast is going to be do with slow component of EPOC, which is going to be with regards to our glycogen or resynthesis of glycogen and removal of lactic acid. Make sure you have key kind of notes and questions developed on this here, and I'll see you in lesson. Thank you. Bye.